Okay, welcome. Before we proceed to more simple problems for our motion of a projectile, let's have some review of the previous lesson. So these are the projectile motion equations. These equations are equations along the x-axis, or considering the horizontal component of the motion of the projectile. So as you can see here, the symbols. Uh, in our equation, we use Vx. It represents the velocity, the horizontal component of the velocity. The Vox, or V naught x, which is the horizontal component of the initial velocity. The x represents the horizontal distance traveled by the projectile at time t. So ang x at times it can be used interchangeably with r, as you can see here. So r means the range. So mingon galit ag range, it is the total distance traveled from the starting point to the final point na nag-stop na siya. So this is r. And sometimes we use also s in our first discussion of rectilinear kinematics. And x naught, or this is the initial position or starting position of the projectile. T, of course, represents the time traveled in seconds. So these are the signification. So dili pud sa sa Vx or Vo. So the initial velocity, as you can show in this projectile, we can replace it with sa unsa nga letter, no? So if this is point A, we can represent the initial velocity as a Va. If this is point B, then we can represent the initial velocity as a Vb. So V sub B, so something like that. And it depends na din sa point. Okay? So for our horizontal components for the projectile motion equations, we have two equations. We have this. The horizontal component of the velocity of a projectile is just equal to its initial velocity's horizontal component. So throughout its trajectory, from the starting to finish, the horizontal component of the velocity is just the same to the horizontal component with of the initial velocity. So it remains constant along its trajectory. So sana all constant. And then the second equation we have here, x, or the horizontal distance or position traveled by the projectile is just equal to its initial position x naught or s naught, depende kung say yung gigamit, plus the horizontal component of the initial velocity times the time. So this is our two equations for the projectile motion. So if you wonder what is the horizontal component of the velocity, this one, the Vox, it is just equal to the initial velocity times cosine theta. So as you can see in the sample here in the projectile trajectory, so if this is the component or the particle and it travels through this direction, so this direction we call this the direction here is the direction of the initial velocity. So the initial velocity has two components. So since this is a projectile manod, unlike the rectilinear nga one way lang siya, this it has two components, the horizontal or the x component and the vertical or the y component of the velocity. So if this is the angle, your horizontal component of the velocity is just equal to the initial velocity times the cosine theta. And then your y component of the initial velocity, or the vertical component of your initial velocity, is just equal to initial velocity times sine theta. So this is the projectile motion equation along the x-axis. So this is the distance traveled, x. So at anywhere in the trajectory, we denote x. But if we use r, it means that the total distance traveled of the particle from starting point to the last point. So here, this is the vertical component of the projectile motion. Okay, as you can see here. So last time we have the Vx denotes the horizontal. Now we use Vy. So Vy is the vertical component of the velocity at time t. So same yapon, no, Vy, or you can use Vay, V sub Ay if katong same yapon equation, no. Let's say if this is point A, then you can change V sub O with V sub A, and then consequently with its components. Okay, so the V sub O not Y, vertical component of the initial velocity. The G is the acceleration due to gravity. Okay, for our SI units, the acceleration due to gravity is just equal to 9.81 meters per second squared. For the English or the imperial units, we have 32.2 foot per second squared. And then y in the vertical equations for projectile motion denotes the vertical position traveled by the projectile at time t. Okay, so ang y is denotes its position. So if you can, so na nagabutang diri nga positive y location is above the axis of the origin. Negative y denotes that the location is below the axis of the origin. So if this is the particle, and then kuhaon nimo ang point diri. So ang equation diri nga atong magamit is this is positive y, because if this is the origin of the particle and this is the x-axis, then amo siya sa ibabaw, it rises. So nisaka siya from the origin, it means it is positive y. If ninaog siya, so from this origin to downward, it is negative y. So this is the position. So a position, we denote the kuan if it's positive or negative. Y naught or y sub o is the initial vertical position of the projectile. So yung initial vertical position from the origin. Okay, so if ato ding origin, so during a sample, if ato origin is at this particle, then its initial vertical position is just 0. But if we say that this is the origin, so yung initial sa vertical position is the height from this one to here. Okay, so ana na siya. So if pasaka siya gikan sa origin, it means positive. Pag panaog gikan sa origin, it denotes negative. So same gyapon ang distance traveled, horizontal traveled by the particle from starting to final, we call that x. We use x, we denote it with x or r. And then delta y, so if you remember our first discussions, it represents displacement, ang delta, no? So delta y, so it is displacement along the vertical position. So the delta y is just equal to y minus y naught, or the final vertical position minus the initial vertical position. So this is our three equations for the vertical components of projectile motion. The first one, we have the vertical component. So the vertical component of the velocity at time t, so kaning denoted by v sub y, is just equal to its the vertical component of the initial velocity, so minus the acceleration due to gravity times time. So this is our first equation for the vertical component. And then the second one, we have here y. So this is the vertical position traveled by the projectile at time t. So y is just equal to y naught plus a v sub v naught y times the time minus 1 of gt squared. So mas may if inyo ni ma-memorize para mas dali ninyo nga kuan magamit. Then the last or the third equation for the the vertical component of the projectile motion, we have the square of the vertical component of the velocity at time t. This one vy denoted by vy squared, or kato siya if this is point A and this is point B sama sa giingon, you can change it into this is the initial and this is the final. So we can change this into v sub b squared is equal to v sub a y squared by squared minus 2g times y minus y naught. So ana na siya. So ang main na nga kwan is this is the final or the second, or let's say the final vertical component of the velocity at time t, the square equals to v naught y squared minus 2g times this one. This is the displacement y minus y naught, or the final vertical position minus the initial position.